All right, let's see. I am 2.15 meters to the left of an unknown charge. You got to draw a picture. Unknown charge. And I am... This is not an anonymous Q, by the way. Let's see, I'm to the left of this. Okay, 2.15 meters, in fact. Okay, so 2.15 meters to the left of the charge, and the electric field is to the right. The plot thickens. Okay. Okay, so notice that it's toward this charge. So we already know that that's got to be a negative charge, because what would positive charge do? Well, positive charge would go toward a negative charge. So therefore, that must be a negative charge. Okay, so Q is negative. Okay. Now, the other way to do this, though, right, is that we're going to use this formula, right? E is KQ over R squared. This electric field is positive when it's away, right? It's really in the direction of some R vector, which is a unit vector that points away from a charge. Okay. So if this thing is toward the thing, then our electric field is actually negative. And that's where the charge will become negative mathematically. Okay. Robots could do that, but I'm not going to do that. I'm just going to, let's stick numbers in here, right? We are solving for the Q, right? So ER squared over K must be Q, right? So that is 1.65 E5 times 2.15 squared divided by 8.99 E9. And I'm just finding the absolute value of our charge. We know already that it's negative. Now, in reality, this thing would be negative. This factor right here would be negative because it's toward that thing. I'm just not going to do that because I think people will find that confusing. E5 times 2.15 squared divided by, and I'm getting that it's 8.484 times 10 to the minus fifth, right? Which, by the way, would be 84.8 times 10 to the minus sixth, right? Or 84.8 microcoulombs, right? And it's a negative charge, right? So we would put a minus sign on there. Coulombs. Either one is correct. Let me just say that people tend to put it in microcoulombs, so this would be a more common answer. It's helpful to keep everything in the same power of 10. That's a whale of a charge for a laboratory. Remember, our Van de Graaff, when it's super hot, is about a microcoulomb, 1 microcoulomb. So there you have it.